Okay, so today, well, I'm Andrew Mason. I'm a Territory Sales Director at Virtuozzo, and I have a pleasure today of having Gianluigi Vigiano with us today. He's a Vertica Principal Solution Consultant at OpenText, and also Igor Ustinov, who is our Product Director for the solution set at Virtuozzo. So I'll cover off on today's the data lake architecture challenges, and then Virtuozzo as a data lake foundation. And then we'll hand over to Gianluigi to actually look at unified analytics with OpenText and Virtuozzo and tell us about the performance and scalability of the combined validated solution. Lastly, Igor will actually take us into the data lake storage architectures with Virtuozzo and the advantages that the combined solution set can actually offer from a storage perspective and also consolidating storage and compute. And then we'll close off with the actual Q&A session itself. So a little bit about Virtuozzo for those of you that do not know about Virtuozzo at this point in time. Virtuozzo has been delivering containerization and system virtualization solutions to service providers and enterprise customers for over 24 years. We have over 680 service provider and channel partners spanning 87 countries across the world, with over 2,000 clusters installed with 700,000 virtual environments running in these environments. Virtuozzo software-defined storage, the key topic of today, is as a result of 12 years of engineering and industry experience, with a scalability of hundreds of petabytes, you can see on the right-hand side, with over an exabyte of storage under management out there in the industry today. Our software-defined storage provides high-performance scalable S3 object storage, iSCSI block storage, and also NFS file storage. And coupled with this, to address the different market requirements, we also provide flexible licensing models. We have a pay-as-you-go lease model, which is for customers that actually require an OpEx-based usage model for licensing, and we also provide annual subscriptions and multi-year subscriptions for the Virtuozzo software-defined storage and also the OpenStack virtualization products that we offer today, including different support SLAs. From the logos below, you can actually see that we address various market spaces ranging from hosting service providers to cloud service providers delivering infrastructure as a service and platform as a service, logos being spread across the world there. And on the right-hand side, right, enterprise and enterprise advanced use cases for financial solutions and blockchain services, AI/ML services, and data protection and malware protection. So for a wide range of solutions and wide range of customers, references, and logos. Right. As business demands for data analytics grow, organizations need to modernize their data lake architectures to actually address the challenges today. So what are these challenges we're dealing with today? At Virtuozzo, we believe we understand the challenges very well. It is primarily driven by the exponential data growth and the need to analyze these large volumes of data quickly for business advantage, for business or for competitive advantage, and for business insights. Exponential data growth brings complexity to managing and scaling these large data lake environments, and also the storage infrastructure. I'm sure you all understand these, having the challenges of trying to take your traditional storage and scale it and manage it at these large petabyte scales. And when it is then coupled to the database or an HDFS environment, it becomes very difficult and complex to manage at scale when you start talking tens of petabytes of storage. And when these data lakes are not managed properly, it results in the creation of many data silos, which makes it difficult for organizations to actually then make data analytics and data available to many more users as these consumers come on board with a unified view of all that data. So ultimately, these legacy architectures and challenges result in escalating costs, as there is no real data governance and a unified view of the data to actually enable the organizations to exploit the actual data that they have. In traditional data lake architectures, there are typically disparate or many or several disparate data warehouse silos, and those are based on legacy architectures and legacy storage. That coupled with a data lake, which is also based on legacy storage, housing structured, semi-structured, and unstructured data. Here we also have the challenge of the data governance across all of these silos, because you have the various data warehouses and the actual data lake that are disparate in terms of repository. So we have the lack of data governance layer and a unified view of the storage across all of this, so we cannot provide a single view of all data. We also have the legacy architecture challenges, where we have a coupled compute and a coupled storage, which limits scalability and makes it more difficult to actually manage. HDFS and Hadoop also becomes very difficult to manage at scale, both performance and capacity, due to the complexity of the environment and the many components. But with the vast adoption of public clouds using object storage for analytics, there's been a shift from HDFS to S3 object storage as the primary storage for analytics engines. So using S3 storage on-premise solves the legacy storage architectures for data lakes, reducing the cost of storage and alleviating these scalability challenges that we're actually seeing today. So for modern data lake architectures, with modern data lake architectures, we can actually address these legacy challenges and solve the problems of having many silos and with not having a unified view of all the data. A data lakehouse is a modern architecture that converges both the functionalities of the data lake and the data warehouse, removing the data silos challenges. This is possible due to the S3 object storage. This is possible due to the S3 object storage, which uses it as the single data store for all structured, semi-structured, and unstructured data. And then we also have the unified, with the single data store, we actually then also have the key aspect of the unified data and governance layer, which sits above this consolidated storage. And this provides a common transactional layer with open table formats and also proprietary table formats, depending on the actual analytics platform in question. Here we also have the decoupling of the analytics compute from the data storage, enabling each of these to scale and flex as needed as workloads themselves grow over time and business demands change. This also supports combining different compute architectures, so we can actually combine virtualization-based and bare metal-based, sharing those same data sources and scaling these independently as the business requirements change. This results in a data processing and analytics platform which is flexible and scales with the business and is more cost-effective at scale. So when we're actually building on-premise modern data lakes platforms, the objective is to have a single repository to eliminate these multiple data silos and have a unified view of all this data. So now with a single repository, the object storage must be able to easily scale for your future capacity needs because you have a single repository. So this needs to be able to scale from tens of petabytes to hundreds of petabytes, for example. It also it must also provide the high availability and resilience needed, protecting the environment against component failures or node failures, because you do not want to experience downtime due to a failure in a single large repository. So you need a really high available, resilient architecture that is engineered for the actual purpose. And to accommodate business demand for near real-time analytics and performance, to gain the business insight and advantage, the performance to process all these workloads is required. So you need a platform that has both that scale of capacity and scale of performance. As your capacity scales, you also want performance to scale at the same time, to enable you to actually optimize the cost as the data warehouse itself grows. You don't want that as your environment is growing in capacity or growing in workload capability, that your costs start escalating exponentially. You want this to actually improve over time. These are all the critical fundamentals when you're building a data lake house or modern data lake on an S3 storage premise. All right, the Virtuozzo and Vertica validated solution supports the modern data lake architecture. It combines the data lake and the data warehouse functions and provides a consolidated data store for your structured, your semi-structured, and your unstructured data. It supports the common file formats, Parquet, Avro, Orc, which for different varying use cases of, let's say, columnar or row-based usage and data compaction, and open to serving many different analytics engines or analytics platforms. It also supports open table formats. These open table formats provide the metadata and the governance and the transactional layer supporting Iceberg, Delta Lake, and Hoodie. And this also enables multiple execution engines. So Spark, Trino, and Vertica can share the same Iceberg open table format and execute simultaneously, but still having a governed transactional layer and a combined metadata and single view of the data. And also, we're supporting the ROS proprietary format, which delivers high performance and better compaction in a relational type model. The high performance and scalable data repository that we're talking about, the single large repository, is based on the Virtuozzo high performance S3 object storage. The high performance scalable S3 object storage is required to deliver high performance. And what we can see is that the Virtuozzo S3 storage has been designed to deliver consistent 10 gigabyte per second get and 2.5 gigabyte per second of put throughput consistently, and this scales as your environment grows. So it also delivers the scalability of both the performance and the capacity, with the ability to scale that capacity to hundreds of petabytes of storage and also hundreds of gigabytes of second per throughput as this actually scales. And this enables the platform to grow seamlessly and also add new use cases and many more consumers and deliver more real-time analytics to the organization. At the same time, the Virtuozzo S3 storage delivers 4x better price performance ratio for reads and writes than throughput compared to alternative, let's say, leading S3 storage solutions. And this is based on the read-write performance capability and the cost of that workload. And the cost of delivering those workloads. All right. Sorry, excuse me. All right. In large scale analytics and data lakes platforms, performance improvement, but cost is also very, very important. So Virtuozzo software-defined storage takes advantage of QLC-based flash technologies to achieve this. The append-only erasure coding is optimized to improve flash endurance and performance, making a low-cost QLC flash tier feasible over more higher-cost TLC-type technologies. This is also supported by the optimized garbage collection and the option to place the S3 metadata on a higher level, let's say a higher endurance, higher performance tier based on TLC, removing that off the QLC, and so we then actually increase the performance of the analytics warehouse and also improve the endurance and the performance of the QLC flash at the same time, giving us further optimization of cost as the actual platform grows. From a price performance perspective, it's obviously very important in terms of scalability. You want your platform to actually become cost optimized or optimize itself cost-wise as it grows. So the Virtuozzo software-defined storage provides linear scalability of performance and capacity, which we've talked about. You start with a couple of nodes, and as you grow, you add nodes to add capacity and add performance across this actual workload. And as you grow the storage by adding these nodes, the Virtuozzo software-defined storage will automatically balance that storage across those nodes, optimizing the performance and actually improving the total cost of the solution itself. And another feature of the optimized cost capacity is the ability for us to then grow what we call non-disruptively grow or widen the erasure coding, so that when you move from, for example, 5 nodes or 6 nodes up to 12 nodes up to 20 nodes, you can then actually go from a 3+2 to a 5+2 to a 7+2 erasure coding, which enables us to then lower the cost and improve the performance as this grows over time. So at this stage, I will hand over to Gianluigi, and he will tell us about OpenText Vertica and how this delivers the performance at scale and for business advantage and taking advantage of the high-performance S3 storage. Gianluigi.
Thank you, Andrew. Next slide. Okay, so I think that, so first of all, what is Vertica? So Vertica is a modern data platform that can be used as an SQL data browser. where you can load and query data very fast. And when we say fast, we mean seconds or sub-seconds. So why is this possible? Because we have our proprietary data format to store the data that is called ROS. I think that you saw ROS mentioned in the previous slide, which is taking advantage of a series of features such as columnar, compression, encoding, and so on that we will see later. Vertica is also an SQL query engine. Now we all know that the customers they are putting data not only into the database but also in other open repository such as for example an object store. Okay, at the end they are putting data on storage infrastructure that are cheaper to be maintained, such as for example a simple bucket in an object storage. And the customer, they are looking for an efficient way to query those data without moving the data into the database. Here is where Vertica comes, okay, as a query engine. We query the data where the data resides without copying the data into the database. The main difference with the previous case, so with the ROS format, is that here you query the data in open format. Everybody knows what is Parquet, ORC, JSON, and so on. So these are the open formats. However, Vertica is mainly an analytical platform and also a machine learning platform. It means that without moving any single byte, you can outside the database, you can build a model, you can train the model, and you can do the scoring inside the database. Next slide, please, Andrew. An analytical platform needs functions, okay? And Vertica has a rich variety of functions that you can simply call in SQL, okay? Rich variety of functions, it means that the TCO of the data platform is decreased, okay? More function means less coding activity and a more readable code that can be executed faster, okay? Because the functions, they are coupled into the Vertica engine code, okay? Then it means speed, okay? So with this amount of built-in functions, there is no use case that you cannot do in Vertica, okay? Time series, for example, they are needed to analyze the sensor data. So for the IoT, then there are mathematical functions, geospatial. You can see the function I highlighted some of them, okay? And this is the reason why one of our customers calls Vertica do more with less, because practically with the engine you get a lot. And just to give you an idea about how many functions Vertica has, next slide, please, Andrew. This is the comparison with other databases or analytical tools in the market. So Vertica has a huge number of built-in functions, near to 800, okay, built-in functions. And as you may see at the bottom of the slide, Vertica is not only the number one. It is number 2, number 3, number 4, and the number 5. And the Vertica number 1 has almost the double number of functions of the nearest, let me call it, non-Vertica competitor. However, this is not the only reason on why Vertica is fast, okay? As said before, there is a series of features in the Vertica Foundation that make Vertica very fast in loading and querying data. And next slide, please, Andrew. So first of all, so Vertica leverage the MPP architecture using the Latin dividend impera motto, okay? In English, it is divided and rule, okay? What is the scope here? The scope is to split the amount of data in different nodes, okay? And so in order to reduce the amount of data that each node manage, so each node that is part of the platform manage. So in this way, each node analyzes only a portion of the data. Then the data, they are organized in columns instead of rows. And this way to store the data allows Vertica to read only the columns involved into the analysis without reading all the content of the row. And storing the data in columns allows to have homogeneous data in each column. And here it comes the advanced compression feature of Vertica that practically dramatically reduce the disk space and further improve the performances, reducing the I/O. Next slide, please. So just to give you an idea on how the compression works in Vertica, the data in the columns, they are sorted, and depending on the cardinality, different encoding algorithms are applied. In this example, for example, if you look at the transaction country, we have multiple values and that are the same. Another example, it could be, for example, the date. Okay, the date related to the data that you are storing every day. If you click Andrew, please, there is animation. Okay, in this example for this transaction country, Vertica keeps only one value. Okay, and the number of times that the value appears. So if you can imagine, you can reduce the amount of data stored a lot. For other columns, Vertica order the data and keeps, for example, the delta from the first value or from the previous value in the column. And if you click again, Andrew, sorry. And here, as you may understand, the compression that you get, it depends from the data. So you cannot impose a compression in Vertica. So the compression depends on the data. And here you have an idea about the compression that you can get depending on the data type. Okay, so if you look, for example, to the network logs, 60 means 60 times compression. So instead of having 60 gig, you have 1 gigabyte, or 60 instead of 60 tera, you have 1 terabyte. Okay. Another benefit of this approach is that in Vertica, we call the compressed data encoded, okay, encoded data, because the data, they are analyzed in compressed format. And what is decompressed is only the results. So here you can imagine that practically there is no computational activity wasted every time to compress and decompress the data. However, as a famous says, power is nothing without control. And next slide, please, Andrew. Vertica gives you also flexibility in terms of the deployment, with the separation between the computer storage layers described by Andrew before. Okay, so the data on each node, they are stored in the object storage. So each node has its own data stored in the object storage. Remember that the DVD and Impera motto before. Okay, and there is on each node a local file system that is used as a cache. Okay, the meaning of this cache is to act as a booster for the frequently accessed data. And then the two layers, that they can scale independently. You can add the resources to each of the two layers where and if they are needed. And just to give you an example, next slide, please, Andrew. So is the previous one? Oh, okay, thank you. So let's say, for example, as an example, that you have there is a company and launching a new innovative product. Okay, usually the company has no idea whether the new product will be a need or not. Okay, if your product is a blockbuster, you may need maybe 100 plus server in a cluster to collect and analyze data, and maybe petabyte of data every day that you have to manage. A less successful product, on the other side, will likely require far less capacity. Not only is planning initially your initial infrastructure difficult, but every product has a life cycle, a different life cycle, grow, maturity, and decline. Okay, you need to be able to manage your database infrastructure to the changing needs of your workload initially and through to the product life cycle. So a lot of companies have constant struggle with this capacity sizing. Next slide, please. And this is not only the case in which a new product is launched, but where there are sizing estimation issues. But virtually every database has a variable workload. So, for example, the dashboard access may fluctuate through the week. The data loads may happen on Saturday or maybe continuous. Weekly reports they are generated on Sunday or maybe at the end of the month. And there is this data science team that, you know, when they wake up, they wanted to have resources to run their experiments. Okay. Next slide. So the compromise that the IT managers and the BDA, the compromise for them, so there are two types of, so there is one type of compromise that they can you know, set up. It is, you know, to try to fit the workload into a fixed infrastructure, okay? Trying to rearrange activities, even negotiate with the users, okay? Or on the opposite approach is to avoid outages or performance degradation. The database they have typically sized to the peak. So and this means waste of resources and cost increase. Next slide. And here is where Vertica help, okay? Because with Vertica you can adapt the resources to the workload without compromises. In fact, you don't need resources. If you don't need the resources for a while, you can shut down them, having back the resources when needed. You can even shut down your database completely if for a certain time you don't need it, and restart it in a later time. Okay, let's see how. Okay, next slide, please. Okay, thank you. So Vertica allows you to create a group of resources that is called subcluster, okay? And all these group of resources, they are working on the same database and on the same data. So practically it's like to have, you know, the nodes split in groups. Each subcluster is independent from the other in terms of resources, and they can have a different size. This means that the concurrency is guaranteed, okay? You can dedicate the subclusters to each workload or to multiple workloads. Next slide. And if you don't need, you know, a subcluster, okay, or if you don't need a workload, you can you know, shut down the subcluster if not needed, or maybe that. If you need less resources, you can shrink the subcluster. Next slide. At the opposite, okay, if you need more resources, you can add the resources to the subcluster to face, for example, sudden increase of activity. Next slide. And then you can restore back the capacity when you needed the full gas for your platform. And next slide. And so what we have seen now, so the flexibility, the speed, and all the other tasks can be applied not only to the database, but also to the external data. We already said that the customer, they are putting data not only into the database, but also in other open repository. And they are looking for an efficient way to query those data without moving the data into the database. Vertica can map this data, okay, as a part of the database. The mechanism is called external table. Okay, if there's simply CSV or what we call open format, Vertica also manages the complex data type. And the good is that you can apply to this external data all, you know, the features that we saw before. So all the functions, the flexibility with the subcluster and so on. And this gives, you know, to the freedom on where you store the data, okay, because you can store the data into the database, or you can leave the data where they are, okay, depending on the value of the data and on the SLA that you need to access this data. So now I am hand over to Andrew, that he will share you an example of the implementation of the modern data analytics platform that we both implemented at a customer site.
Thank you, Gianluigi. All right. So it's always great to have a customer reference study that one can talk about that actually addresses the points that we've been talking about through the actual presentation and webinar. So the important thing here is that our Turkish customer, in conjunction with our system integrator, Scitech, had very stringent requirements for their data or modern data lake platform based on both Vertica Spark Trineo engines and a performance or high performance scalable S3 object storage required to be coupled with this to deliver the scalability that they required. They needed 100, to meet the criteria, we needed to deliver at least 100 petabyte scale with high throughput for the data ingest to satisfy their consistent ingest capabilities. And this was actually tested and proof of concept. They chose Virtuozzo as a compelling solution because of the price performance coupled with that scalability and the integrated compute as well, which we talked about, having your independent storage or being able to have virtualization coupled with that Virtuozzo storage solution. Virtuozzo actually managed to satisfy that performance demand, delivering consistent 3 gigabytes throughputs per second per node for the put requests. And this is ultimately a 30 petabyte deployment of object storage with both high performance analytics throughput with Vertica and also a longer term, a lower class of storage for the other data use cases. At this point, I will hand over to Igor, who is going to tell us more about the different architectures you can deploy with the Virtuozzo object and data lake platform and the virtualization capabilities that offer to support workloads such as this.
Yeah, thank you, Andrew. So with Virtuozzo, you can benefit from the flexibility that Virtuozzo gives you in terms of how you can use it, because our solution is designed to be flexible. You can use it as a storage only, using the hardware which is designed, specified for the storage only configurations, or in continuation what Gianluigi mentioned, usually customers, and we see this, they run multiple clusters, different workloads that have different requirements. You can benefit also from our compute services that we have as part of our platform, enabling you virtual machines and Kubernetes running along with the storage nodes, and at the same time having the bare metal servers for those workloads, heavy workloads that benefit from the bare metal performance, having them on bare metal, and workloads like reporting dashboards, which are have less requirements for the performance and can be run in virtual machines. You can easily kind of leverage flexibility and run them in virtual machines or Kubernetes. Next slide, please, Andrew. Also, I would like to mention here that multi-tenancy and isolation capabilities that we offer with our storage. First of all, you can do the isolation on the hardware level by splitting, by using different types of media, different types of storage disks. For example, you can have a tier of SSD disks, QLC disks, as we answered in the chat, and I have HDD tier disk, for example, use it for another types of workloads, and expose these types of data in form of the storage classes to your external users of the storage. At the same time, you can add also, on top of this, you can add additional isolation of these workloads, because as we discussed, different workloads have different requirements, and you want to spread the resources of your storage equally and avoid overloading. And you can leverage our limits for requests and throughput limits that you can apply to on the bucket level or user level, at the same time limiting your data producers or data consumers by the capacity limits. And for security, as part of our storage, your users and teams, they can leverage cross-team bucket access policies to share access to their buckets with another teams, and in an easy way. And on the top of it, leveraging our multi-tenant self-service panel, where each team can get a view of their own resources and buckets that they own. The next slide, please. And for the data protection and security features that our storage has, in addition what Andrew mentioned, to the kind of functionalities, core functionalities of storage, like erasure coding or checksumming that we do on the storage to make sure that your data is durable and safe, we provide functionalities for S3 storage, like S3 object versioning, S3 object lock for the data where you want to avoid situation when the data accidentally removed and want to preserve data or whatever, to make sure that the data is preserved. And additionally, you can leverage multi-site geo-replication for S3 storage, and having multiple sites where you replicate the data just in case your primary site will fail. And for security features, we have data at rest encryption, also data in transit encryption for which can be benefit when, for example, your storage runs in the data center, which is not owned by you, and you want to avoid eavesdropping attacks for the traffic which flows between nodes. So this data also can be encrypted between nodes. And also we have a built-in firewall management for the storage nodes, where you can control from where, from what subnets access can be done to your storage nodes, to your storage services, to S3. For example, you can disable SSH connection to make sure that nobody can get in to your host operating system on the storage nodes. The next slide, please. And storage automation functionality. So we have it's a functionality on S3 storage. So first of all, you can leverage automatic cleanup of the data by setting lifecycle expiration rules for the new data which is written to your buckets for your objects, and for example, to make sure that your data is cleaned automatically, and you do not have a stale data stored in your storage, and which can be useful, for example, if you have a streaming of the data going to your small objects, going to your storage, and it's can be quite useful functionality in this case. And the event notification. So it's standard Amazon S3 feature. So it's we also have implementation of it. So it's this feature helps you to avoid unnecessary polling of your data in your S3, and benefit from event-driven workflows where your data consumers, usually in the kind of complex data pipelines, you may have different data producers and separate data consumers. So when the data producers put the object, for example, if it's a streaming of the small objects to your object storage, your data processing jobs will can be notified with the notifications instead of constantly polling your bucket. For example, if you have millions of objects, it becomes quite a complex task. And here you can manage leverage notifications and get updates as soon as new data lands into your S3 storage. And here, let's move to the questions and discussion. Andrew, back to you.
Thank you, Igor. And we have John, Luigi, and Igor to help us with the Q&A. All right, so let's have a look at some of the questions that have come through. So Igor, I think the first one is probably for you, but so what type of drives are recommended to get the highest performance from the S3 storage? I suppose it is use case related, but if you can actually highlight on sort of which drives are the best and deliver the best price performance for these type of requirements.
So I have given the answer in the chat, but let me elaborate a bit on this. So for those numbers that we show on the slides, 10 GB per second per node for read, For those type of configuration, we would recommend using all flash design. And in this case, kind of the most cost-efficient media that is available on the market right now is QLC drives. And that's what basically also we used in that reference that Andrew spoke about. It's a QLC drives. And on top of it, if speaking about hardware, we would definitely recommend using 100 gigabit networks for this type of configuration as well. So if you're interested, we can follow up later and discuss the hardware specification individually.
Perfect, thank you. Then there's another one, is how many nodes can be part of a single cluster? So how big can we actually scale?
So our storage is scale-out architecture. So you, as Sandra mentioned, you just add nodes and you add capacity and performance. So our storage can scale to 100 nodes and more. And as said, it's designed this architecture of our storage is designed not having some bottleneck or any limits here. Yes.
Then we have a very interesting one. I think we did touch on this in the presentation, but it's worth highlighting. But how is it different from vast storage? They also use QLC for data and MLC for metadata. But I gather it's not just the storage. It's also more about the solution capabilities of combining different workloads and the compute and the storage as well.
Yes, the main difference from our perspective is the cost efficiency. So we consider our solutions more cost efficient, and at the same time, yes, our storage is optimized for QLC drives to eliminate their wearing out. From this perspective, that's a bit the same approach. Yes.
Thank you. Gianluigi, there's one for you. What are the selling point of OpenText Vertica compared to BigQuery and Snowflake in these data lake environments?
Here it will take hours, but I think that we can say costs, flexibility. Vertica is hybrid, okay, and I mentioned the function. So BigQuery, so we had to anonymize, the name of the competitors, but BigQuery stays in the middle of the slide that I show. So, and the function again is a number of built-in function. It means that you have to write less code, you are more efficient, and you use less resources. And in BigQuery, you pay, you pay the usage of the resources. So just to recap, flexibility, speed, and number of built-in functions. Okay. Then there are other, differences, but I think it will take too much time. Okay. We can explore it if who posed the question is interested. We can have a session. Okay.
All right, and then we have another one. Can you build your storage cluster with all flash or NVMe or hybrid altogether?
Yes, so that's what I have covered on my slide. So you can build it with a mixed tiers. You can build it hybrid, and so all flash is definitely yes. And additionally to you can do this hybrid. You can have a tier of all NVMe or SSD, and additionally a tier of HDD drives. And at the same time, you can have a cache, SSD cache for your HDD drives, and expose this data in form of storage classes and have them both on the same nodes. And for example, use all NVMe tier for data analytics workloads like Vertica, which are sensitive on performance, and HDD storage tier use it for backup workloads, for example, to store your backups.
All right, and we have another one. What about the data center to DR licensing, or do we need to procure additional licenses to perform the data center DR replication? So in the object store, we have the object replication, the geo-replication built into that, and the licensing on the object storage platform itself is based on, or the platforms, and if you have multiple sites in a hybrid environment, that is actually based on the used capacity of the S3 storage. That is in the OpEx model. Otherwise, you can actually use the subscription-based model where you also license for the full usable capacity of the platform you're actually operating on. So the licensing is based on the used capacities for the different sites that you're actually working on. Try and see, there's another question. You got another one for yourself. Does it support even Intel mixed generation together in the same cluster with full capacity? So obviously, as we're going to scale over time, we're going to be adding nodes of different generations if we're adding nodes a year or two down the road.
Yeah, Virtuozzo is software-only storage solution, and based on we do not have limitation in terms of what type of on the hardware that you can use, and you can even use storage nodes with a with a bit different capacities, but you need to be careful here when you design the hardware, because to make sure to have your storage nodes the balanced in terms of the performance, so that they provide the same level performance to keep it balanced, because to keep it balanced for your S3 for S3 applications mainly, so that they would have the same level of performance getting from all the nodes in the cluster. But yes, you can use different generations, and if the resources of these CPUs is enough for our object storage, then you will not see the difference in the performance between them on the line.
But if I can add, Vertica is the same. So it is a software only, and same comment about you should keep the homogeneous resources in the subcluster. So you can use whatever you want, but just pay attention, because if you remember the divide and rule, so divide and impera motto, so practically in the subcluster, you always go to the speed of the slowest node because it is MPP. But you can use whatever you want, even ARM. Vertica support even ARM processors.
Okay, so we have another one. How many node failures can be supported in a case of a 10-node cluster? So obviously, I think you were referring here to the S3 high-performance S3 storage cluster. So it's on in that context.
Yeah, in the case of 10 nodes, the most reasonable in such configuration would be using of erasure coding 7+2. So for this 10 nodes configuration, you may have you may lose 2 nodes, preserving your data with the 7+2 erasure coding setup.
And Gianluigi, in terms of, let's say availability and node loss with respect to the Vertica Analytics processing, how do you tackle this from a Vertica point of view?
So Vertica, here I have to speak a little bit about subcluster. Practically there are what they are called the primary subcluster, and the primary subcluster, they count for the quorum. So you should have at least half of the node +1, okay, in order to keep in order to maintain the high availability. If the number of nodes goes below this value, practically the cluster is switched in read-only mode. So you can query, but you cannot write. This is valid only for the primary subcluster. For the secondary subcluster, they can shrink from 10 to 1 node, and they continue to work.
Okay. Thank you. All right. It looks like we've answered all of the questions. If we actually have missed any of the questions. Okay. Sorry, some of it actually more coming in as we talk. So I think we have a minute or two. So let's actually pick them up while we're here. Is it possible to increase the resilience from that 10 nodes scenario that we talked about, Igor?
Yes, we have a 17+3 erasure coding schema, which can help you to increase. For example, on a larger scale, you can increase the number of failures that you can tolerate. Also, we have a possibility of failure domains, where you can configure failure domains on the room level. For example, you can have storage nodes in different rooms, and also control failures that you can tolerate on this level.
Then we have another question coming here. So is the platform OEM hardware agnostic? I think, Gianluigi, you answered that from a Vertica perspective earlier, agnostic even including ARM CPUs, but from the Virtuozzo S3 object storage perspective, or let's say the virtualization capability to consolidate workloads, is this OEM hardware agnostic, Igor?
Yes, so we are software only, and yes, we kind of we can run. We do not have any specific hardware that we can run on, so we can run on any hardware that is satisfies the requirements for this high performance, based on basically based on your performance requirements.
Excellent, thank you. All right. So it looks like we have covered all the questions. If more questions, please, if you have more, do answer. And if there's some questions we've missed either in the chat side, because it's not as easy to track as in the Q&A, we will actually reply to those questions and get back to you on them. But thank you for joining us today. And if you'd like to learn more, you can go to virtuozzo.com, the high performance storage, which talks about our high performance S3 storage and for big data analytics and big data lakes. You can also go to OpenText.com, the product's Vertica Data Platform, and see more about the actual Vertica Data Analytics platform itself and how that actually works. And you can reach out to any of us. You've got the panelists, you know who we are. You can reach out to us, or also you can reach out at virtuozzo.com/partners. So you can actually approach our distributors and our resellers, market space, or service providers that provide cloud storage capabilities, because you could obviously got on-prem capabilities, but our service providers delivering S3 cloud object storage could also host hybrid analytics platforms for you, that or let's say on cloud, or also hybrid combined on-prem and on-cloud solutions for you. So please do go and have a look at virtuozzo.com/partners if you're looking for a provider as well. Thank you very much, and at this stage we will then close off the webinar, and as Tatiana mentioned, we will share the webinar with everybody that has been in attendance of the call. Thank you, Gianluigi, and thank you, Igor. I really appreciate your time and spending the time with us today. And all of you out there who've spent the time with us, thank you as well.
Thank you.
Thank you.